Hello, and welcome to the home stretch of 600.2x. We've only got one more topic to cover, and it's an exciting topic, machine learning. In fact, machine learning is probably the most exciting topic in computer science today. Why is it so exciting? Because we're in the era of big data. The world is collecting data at a ferocious rate, and machine learning, as you will see, is a really good way to try and make sense of that data. The first question we should probably ask is, what is machine learning? Superficially, you might say that machine learning deals with the question of how to build programs that learn. However, in some very real sense, every program we write learns something. For example, in 600.1, people implemented Newton's method. What does that do? It learns the root of a polynomial. But in fact, most people would not think of Newton's method as machine learning. They think of something more exotic, the kinds of things we see in science fiction movies. Well, let's try and be a little bit more precise than that. I like to think of machine learning as the process of automating automation. Let's think about a computer program. What does it do? All it does is follow rules. Where do those rules come from? Most of the time, they come from people who write programs, which define the set of rules that Where do those rules come from? They come from programs. Where do those programs come from? People write them. Well, machine learning is about getting computers to program themselves. The fundamental idea is to let the data do the work, and then to automatically generate programs that, given data, create useful outputs. Let's look at it pictorially. Here's the traditional programming model. You sit down and you write a program. You then take that program and some data, put it into a computer, or maybe more properly, I should say, an interpreter, and out comes some output. And if you're a good programmer, the output is what you hoped it would be. If you're not a good programmer, well, it's debugging time. Machine learning is a different model. We start with the output and the data both, put those into the computer, and really maybe I shouldn't say computer here. What I should probably say is learning procedure. That is to say the machine learning. And out pops a program. Once we have that program, we can then put data into the new program, and it will produce outputs that we hope are useful. Backing up for a minute, getting away from the pictures, how do people learn things? Well, a lot of students rely on memorization. What's that? It's the accumulation of individual facts. It's not a great way to learn things. It's limited by the time available to observe facts, the number of facts there are to observe, and the memory to store the facts. It's great if all you want to learn is a trig table or the periodic table, but for more interesting things, it just doesn't cut it. The other way people learn things is generalization. That involves deducing new facts from old ones, and that's the core of machine learning. How do we do that? Well, that's hard, but let's look at an example. Suppose I tell you that's a chair. Then I tell you that too is a chair, and that's a chair. Now I ask, is this a chair? Well, perhaps from looking at these three things, you've been able to reach a generalization that would let you deduce that that too is a chair, and perhaps also deduce that that is not a chair. This process of deduction is limited by the number of facts and, of course, by the accuracy of the deductions. So if, for example, I showed you only that chair, you might deduce that this too is a chair because after all, they're both blue.